And in the series of solving simple problems of rotational dynamics, we have yet another simple problem. You can see the picture and read the transcripts of the problem, and this problem statement is in the system of bodies shown in figure. Okay, system of bodies. The mass of load M1. Here M1 is this, I think. This is load is this, and the mass of the stepped pulley, that is this, ये अंदर में घुसाया हुआ है, stepped pulley M2. The moment of inertia of the pulley I naught relative to its axis, this one. Okay, I naught has come moment of inertia, and the radii of the pulleys R1 and R2. R1, इस पुली का रेडियस R1 होगा और इसका R2 होगा. Okay, are known. Okay, R2 is greater than R1. Yeah, I guessed it right. The mass of the threads is negligibly small. That's fine. Find the acceleration of the load A1. Okay, and the center of mass of the pulley A2 in the lab frame of reference. Great. Laboratory frame of reference. So we choose a lab frame that is also at rest, so we are going to choose a lab inertial frame, and I'm going to fix it rigidly with the ceiling. Now, though I don't need x-axis, so I can only take the y-axis, and this is in vertically downward direction, and the pulley can move, or the block, that means the load can move in positive and negative direction, both negative direction of the y-axis, depending on the masses of the bodies involved in this motion. And our pulleys are performing only purely rotational motion. About which axis? I can get an instantaneous axis of rotation here. I can. You should too, because this will be a good habit if we do it in this way, because we need to find out the acceleration of the pulley or the load with respect to lab frame. So an instantaneous axis of rotation in the lab frame is always good, and we can easily guess here where is the instantaneous axis of rotation in such cases. Believe me, because you know what? The thread attached to the ceiling is inextensible. This thread is inextensible. Okay. So the instantaneous axis of rotation of the pulleys pass through this point. This is point A, named here A. This is the point of contact between the pulley and the thread, and this doesn't move, so your instantaneous axis of rotation passed through it. Yes. In this case, the instantaneous axis of rotation is perpendicular to the plane of the drawing. I guess its chosen positive direction is indicated in this figure, and that will be into the plane of the paper, because a cross has been added, so this axis is basically into the plane of the figure. Anything into the plane of the figure, any angular acceleration or angular velocity, though we will be dealing with angular acceleration only in such cases. If it is clockwise, then we will take it positive, and if anti-clockwise, we are going to take the angular acceleration as negative. So now instantaneous axis of rotation has been decided, and in such cases Instantaneous axis of rotation is quite visible. If somebody put a thread, inextensible thread, we can always find the instantaneous axis of rotation. Now I'm going to write down in the second stage of this problem solving the equation of motion, and I'm going to write down the equation of the motion of the load, which is in translational motion. And I can see here that two forces are acting on it, the tension and gravity. So I'm going to write according to our chosen coordinate system. I'm going to write its equation of motion as m1g minus t equals m1 a1. So a1 is the acceleration of the load, and t is the tension in the thread on which this load is attached. Yeah, this is another thread, I don't know. Now I'm going to write the equation of rotational motion of the pulley. This is stepped pulley relative to what? The instantaneous axis of rotation. Well, because we are working in lab inertial frame of reference, so I'm going to write down the equation of motion of this stepped pulley. And about this instantaneous axis of rotation, we don't have the moment of inertia of the pulley. Moment of the inertia of the pulley is given about this axis, not this one. So I would like to write it simply I, but what are the torques? Who are producing the torque about this axis of rotation passing through A? mg is producing a torque in clockwise direction, m2g. So this torque will be taken positive, and tension is going to produce a torque, tension T is going to produce a torque in anti-clockwise direction. So I'm going to give it a minus sign, and simply I can write the torque of the weight is m2g multiplied by r minus torque of the tension is this distance. This distance is simply r2 minus r1. So I'm going to write down the torque of tension as T r2 minus r1, and this is my equation number 2. Yeah. Here no, this is not the complete equation. This is only torque, and I'm going to write torque equals net torque equals I alpha about the axis of rotation. About this axis of rotation, the moment of inertia moment of inertia of this stepped pulley about this axis of rotation is I suppose it is I, and so it can be written as I multiplied by some angular acceleration beta. This is our equation number 2. Yeah. And now what? T naught is not in the upper thread attached to the ceiling. This one is not producing any torque because it is passing through the axis of rotation. And this I is I think by using parallel axis theorem we can write it I equals I naught plus mass of that pulley was m2, and outside pulley this was nothing, उसको कुछ mass was नहीं है, m2 multiplied by r1, radius is r1, so r1 square. So we got another equation 3. Though this is not the equation really, but it can be used in solving the problem. Now I am going to write the equations of kinematic equations, because kinematic equation, from where I can get the kinematic equation? This is simple. Always look for condition of inextensibility of the threads. So which thread is inextensible? You know, this is, so its acceleration written its acceleration as a2, and its acceleration as a1. So A2 is simply, and this is the instantaneous axis of rotation with zero velocity. So from this I can simply write its acceleration A2 equal to its angular acceleration beta multiplied by r1, and it is rotating in clockwise direction as well. So its acceleration of its center of mass is beta r1, yeah, and what I told, acceleration of its center of mass. Okay, it is not very much correct but not very much wrong. A2 equal to beta r1, that will be fine, yeah. And because this is at rest and this is moving about it in this circle, this will try to move in this circle, so its acceleration is fine, acceleration direction is fine, and this will be beta r1, no problem at all. And what about this acceleration of this point? And this is, of course, its acceleration can be written as a1 equals beta r2 minus r1, but this is not according to our axis of rotation. We promised ourselves that all the acceleration all A2 sorry, its name was A1, and A1 equals beta R2 minus R1. I have already written R1 minus R2, but this should be R2 minus R1. Yeah, all right. Now what? This is an anti-clockwise direction. This beta is negative here, because this we have promised ourselves that all the angular acceleration in clockwise direction we will take it positive, and all the angular accelerations in anti-clockwise direction we are going to take it negative. So I am going to put a negative sign here. A1 equal to minus beta R2 minus R1. Is that correct? Everything I wrote down, everything correct. So these are the equations. Instantaneous center of rotation I got. So I'm going to write down everything. Beta is the angular acceleration of this, and so we can I did it right. What about this? Yeah, this angular acceleration is beta as well, but in another direction. So I wrote everything right, and now I'm ready to solve these equations to find whatever we wanted to get. We wanted to get A1 and A2, and I guess you can find it. So these are the things you can use in your solution: the coordinate axis and the funny instantaneous axis of rotation. If you are going to get a chance to get instantaneous axis of rotation, must take it. It is simple. It is at rest. So thank you very much for watching.